Hello, class. Here's the second of the two recorded lectures for section 12.1, which is the goodness fit test. So what we did in the first lecture was walk through the calculation of the test statistic um, for the goodness fit test and compared it to the chi-squared value that we got off the table and made a conclusion. And what we're going to do now is the same style calculation using technology. And so just to refresh your memory is this was our problem. Employees want to know which days, employers want to know which days of the week employees are absent in the 5-day work week. And what we did here is they took a sample of 60 and the observed value is what's in the table. And we're going to see if it fits what we call a uniform distribution, which implies that the same number of absences occur each day. So we walk through the test statistic calculation, which checked the, excuse me, checked the previous recorded lecture for those calculations. And we ended up comparing a chi value from the table of 9.4 compared to the calculated of 3 of the test statistic. And so since 3 is less than the 9.4, we do not reject. And so there wasn't sufficient evidence to conclude that the absent days do not occur with equal frequency. So again, when we set this up using technology, we're going to keep, of course, with the same null and alternative hypothesis. So again, the null hypothesis is equal frequency and the alternative is unequal frequency. And so when we did this calculation, I presented it in this table format. And so, and back in the day before the technology was available, this was the only way that you could do it. So again, when I was sitting in your chair, this is how we did this test. Just like the Z-score test, there was no fancy norm old CDF on your calculator or norm.dist in the spreadsheet. And so we ended up using these tables. But now we have that kind of capability. So we're going to demonstrate it using the spreadsheet, and then we'll also demonstrate it using your calculator. So again, the same degrees of freedom, the same hypothesis. And so now what the calculator, or excuse me, what the spreadsheet has is a chi-squared dot test, which allows you to take the data and it will do a calculation for the p-value, which corresponds to the p-value for the test statistic that we calculated in the previous lecture. And so once that p-value is calculated, you compare it to the significance level, alpha. And if it's greater than, then you do not reject. And if it's less than, you do reject. So similar to all the other hypothesis testing that we do with regards to the right tail test. So how do we do this? Well, erase those for people. And let me try to make this a little bit bigger. There we go. And so as you can see, I also did the calculation by hand in the spreadsheet to make sure I did it right, number one. And number two, just reinforce that you could use a spreadsheet as a calculator, and it's very, very helpful. But to calculate the p-value, you do need to put both the observed, which is these number of absence, and the expected value, which you could see is 12 for each one of the days. And so the way to set this up is you go up to more functions. And again, it's the CHISQ.test. You hit OK. And so the beauty of this is the actual range is the actual test data. So again, you highlight the test data. And then the expected range is the expected value. So you highlight that. And basically, it'll give you a p-value with regards to the right tail test. And so you can see the p-value is 55, almost 56%, which is a lot bigger than 5%. And so if we go back to the presentation here, you could see that this was the value here. And so again, the decision is not to reject the null hypothesis. Again, not enough evidence to conclude that the absence occurs with equal frequency. And so you could see that again, test statistic, p-value. And so there's also a calculator where if you look at your TI-84, 83 calculator, there is a command called chigof.test. And so check out the book. They'll give you some more details on how to get to that. But the beauty of that is, again, you enter the data. And it looks like that you enter the data. L1 is the observed, and then it looks like you have to indicate L2 would be the expected, and you have to plug in the degrees of freedom as well, it looks like. And when you do that calculation, out will come a p-value. And so this is for, excuse me, a different problem, as you could see, but the book also talks about the chi-square.test for the XL as well. And so when you walk through the homework in this section in our ALEKS, you'll find that you have to do the calculation using the test statistic and also some calculations using the p-value. So you'll get a chance to practice both of those. So that ends the recorded lectures for section 12.1.